Hello everyone and welcome back to Nunley Math. I'm your host Aaron Nunley as always. Thank you so much for joining us here today as we are coming close to the end of our study of linear equations in single variables and how we can use algebraic properties to solve them. We've got one or two more videos left in this series, and we're going to tie up a few loose ends, and then we're going to move on to something else here very shortly. But thank you for being a part of this. I'm going to start this video off much as I do my other videos and much as I do in my own classroom, and that is I'm just going to review some concepts with you that might be important here today. Notice that I have for you a linear equation in one variable. I'm going to call that my original or given problem. And what I'm going to do is I'm going to make some changes to this equation in order to find what value of x makes it true. And we have to keep in mind that I can only make changes to this problem that are allowable under certain algebraic rules that we've talked about in earlier videos. For example, here's the first change. And I want you to look at this and see if you can figure out what change I've made and what property allows that change to occur. Hopefully you've noticed that I've taken all my minus signs and changed them into plus negative signs. This is not something that's required in equations. You can solve them as subtraction, but as I tell my students, most of the time subtraction makes things a little more complicated. It's a lot easier to just make them into adding the opposite. The property that allows me to do that is called the definition of subtraction. Subtraction is the same as adding the opposite. Here's one for you. Any idea what I did here? I've taken my -3 and I've distributed it to everything in the parentheses. Any idea what property lets me do that? Distributive property. I'm then going to do this. Any idea what happened there? Look closely, look for the changes that took place. The big ones are that I moved this -15 over here so that all of my x's are first and all of my constants or numbers are second. Since it's all addition, I can move those without changing the solution. That's the commutative property. Notice then that I have grouped my like terms together. What property allows me to regroup addition? That's the associative property. I'm then going to combine my x's to a single term. This is the one that I tell my students is the most difficult to remember because people like to say it's combining like terms, but we have to have a justification for why those terms can be combined, and that is a form of the distributive property. I then add my -15s together. When I add my -15s together, I get -30. That's just simple computation or addition. I add 30 to both sides. That's a property of equality. I perform a little bit of computation here. I got rid of my +0 using the additive identity. Remember, adding 0 doesn't do anything. Any idea what I did here? I used the property of equality. Notice that I multiplied both sides by the same amount. The property of equality says as long as I do the same thing on both sides of the equation, I will end up with solutions that are the same. Notice as well that I used the multiplicative inverse when I did that. By using the multiplicative inverse, I ensure that after multiplying those together, one of those terms becomes a 1. And then I just perform some computation. Finally, I do this. I got rid of a times 1. What rule says you can get rid of a multiplied by 1? That is the multiplicative identity. As I started off telling, the last thing I do is this. I got rid of the times 1. What property allows me to do that? That's the multiplicative identity. Notice as well here, like I've talked about before, you have this equality computation identity pattern here, equality computation identity pattern here. Most of these are going to end with some version of this. Notice that the definition of subtraction and distributive property usually happen very early in the problem. Commutative and associative and distributive tend to happen in the middle, and occasionally you're going to see a symmetric property or property of symmetry thrown in here as well. Hopefully that's a good review for you. The other thing I'd like to do very quickly is I'd just like to remind you that the property of equality says I can do whatever I want as long as I do it to both sides. Or whatever I do to one side of the equation, I must do to the other as well. The property of equality allows you to change the appearance of the equation without changing the solution. And so we've worked through several examples where we use the property of equality to solve problems like this. So for example, maybe I want to get rid of the 15. Well, or the 15x. I can subtract 15x from both sides. And of course, we a long time ago stopped writing the 0 step using the identity property. And then I have a two-step equation. Property of equality allows me to get rid of the 23. Remember, that's a plus 0 that we've stopped writing down. And the property of equality allows me to divide by negative 27 to get 1x equals 2. And of course, we don't write the times 1 anymore because we're cutting down on the amount of work, even though we know in our head that's actually what's taking place. Now, this is what we've learned so far. This is how we've been solving these. But I want to tell you the property of equality can actually be used in a lot of interesting and creative ways in order to make problems that seem difficult become a lot easier to work with. Let me show you what I mean by that. A lot of students, by the way, we can check our answers as well. A lot of students look at this and they get very, very freaked out by the fact that you have 3 fractions in this equation. People tend to find fractions to be difficult to work with. If I wanted to do this using what we already know, I would have to take 2/3 x and combine it with 1/2 x and come up with something. Then I'd have to subtract the 2 x's from both sides. So I've got a fraction minus a whole number. And then I'm going to have to get rid of that fraction, whatever it is, using the property of equality and multiplicative inverses. It all sounds fairly complicated, but there is a much, much simpler way to work through this problem using the property of equality early on in the problem, and that is this. If I look at my denominators here, let's get a marker. I have a denominator of 3, a denominator of 2, a denominator of 6, and for all intents and purposes, this one has a denominator of 1, if I write it in fraction form as 2/1. The property of equality says I can do anything I want to this equation as long as I do it on both sides. So I'm going to do something kind of cool here. I'm going to multiply both sides by the same number, and that number is going to be a 6. I'm going to multiply both sides of this by 6. Let me erase my ink there so you can see it a little better. I'm going to erase this and multiply through both sides of this equation by a 6. Now, I haven't explained why I picked 6 yet, but I'll talk about that in just a second. What I want you to realize, first of all, is this. If I do 6 times 2/3, that's 12/3, or 4. If I do 6 times 1/2, that's going to be a 3. If I do 6 times 5/6, that's 36, which is 5, and 6 times 2 is 12. Do you understand what just happened there? By multiplying everything in this by a 6, I end up getting rid of my fractions. Think about that for just a second. By choosing the right number to multiply through the entire equation by, I was able to deal with those fractions at the beginning of the problem when they were all fairly simple and make them go away. Because this equation is pretty easy to solve. Combine like terms on the left, property of equality on the negative 12x, divide both sides by negative 5, and you get x equals -1. Look at how much simpler that was than having to go through and deal with all these fractions. That brings us to the big question. How did I pick these numbers? Notice my denominators are 3, 2, 6, and 1. 3, 2, 6, and 1. And I wanted to get those so that the denominators were all 1. The key to this is I need to multiply through the entire thing by the least common denominator. The least common denominator for 3, 2, 6, and 1. Or I need to find the smallest number that can be divided by all three of these. Notice 6 can be divided by 3, 6 can be divided by 2, 6 can be divided by 6, and 6 can be divided by 1. That's how I knew to use this one. Does that make sense? Let's try another one. 8/5 y plus 2/3 y equals 23 minus 1/15 y. I'm going to look for the least common denominator here, or the smallest number that can be divided by 5, that's here, 3, which is here, this is technically 23 over 1, and 15. Can you think of a number that can be divided by all of those? Hopefully you've realized that number is 15. And I can take that 15 and I can give it to everything in these parentheses. Notice this one should have been red. I missed that. I'll fix that later. I can give that 15 to everything on the left side, give that 15 to everything on the right side, and I end up with this equation. Now, 15 times 8/5 is, let's see, 15 times 8 is 80 and 40, 120 over 5, which will simplify. This is 30 over 3, which will simplify. This is going to be, what, 230 and 115, 345, and 1/15 of 15 is a 1. Now, I realize that there are some easier ways to multiply 15 times 8/5. My goal today is not to talk about multiplying fractions. Hopefully you have an efficient way for doing that. If not, I'm going to put together a pre-algebra lesson on multiplying fractions that you may find useful. But for now, let's just say that we're going to multiply the numerators and the denominators and then divide. This is 120 over 5, which is 24. There again, I do know there's a more efficient way to do that. I just don't want to get into that right now. Notice how much easier this equation looks than the equation you started with. That's kind of messy. This is very clean and neat. Combine like terms, subtract 1y from both sides, and divide both sides by, this should be positive 33, which should give you 10 and 15 33rds. Not bad, right? Notice, by the way, I did go ahead and simplify that to 10 and 5/11ths. Here's a thought for you. You can do something similar to that with decimals. Any idea what we could multiply both sides of this equation by that might make it easier? Take a second and think about that. You might want to pause the video to give yourself some time. I'm going to keep going. I'm going to multiply by 100 on both sides. The reason I do that is I'm noticing that this has 2 decimal places, 2 decimal places, 2 decimal places. So I'm going to multiply by 100 because multiplying by 100 moves my decimal 2 places. When I multiply all those by 100, I get this. Notice these are all real nice, neat, easy numbers. Once again, we can use the properties we already know in order to solve this. If you want to see that a little faster, you can always pause this and work your way through it again. I think we're getting pretty good at solving equations like this, so that's not where I want to focus our time. Our time and energy is best spent thinking about what we can multiply through by. Notice there again, I use the symmetric property to switch that around. How about this one? Any idea what you could do here? If you need more time to think about it, you might want to pause the video. I'm going to go ahead and tell you that I'm going to multiply both sides by 1/1000th. Notice this is 4 zeros, 3 zeros, 3 zeros. I don't want to divide by 10,000 because 80 divided by 10,000 or times 1/10,000th would work, but 3,000 divided by 10,000 is going to give you a fraction anyways. So I'm going to go with the lowest one here, the 3 zeros. Some people say, well, couldn't we divide both sides by 1,000? You could do that as well. Just remember that division is the same as multiplying by the reciprocal. I like to pick this because this is the one people are less familiar with and probably could use the most practice on. So I multiply everything by that 1/1000th, and I end up with this nice, neat equation. Again, the focus here is not on solving this neat equation because you should be pretty good at that by this point. If you're not really comfortable with that, you might want to go back and watch some of the earlier videos in this series. One last thing I want to make sure I tell you before we go on, and that is this. It is extremely important that before you clear out your fractions, for example, here my common denominators are 5, 3, 4, and 5. The common denominator is something that can be divided by all of those. Before I do that, I want to do the distributive property first. The distributive property first. So I'm going to multiply everything in here by 3 and everything in here by 2 before I try and clear my fractions. Once I've done that, now I'm going to look for the LCD, the least common denominator, for 3, 4, and 5. If you're not sure what that is, you might want to pause the video and think about it rather than me just telling you. I'm going to go ahead and say that the least common denominator is 60. It's a 60. Notice that 60 times 6/5 is going to be 72. 60 times 1 is going to be x. 60 times a half is going to be 30. And 60 times 6/5 is going to be 72. Here again, from here, the equation should be pretty easy to solve, so we're not going to mess with it. Again, from here, the equation should be pretty easy to solve, so we're not going to bother doing that in this video. I'll let you work that out on your own. That's actually all I have for today. Here again, it's just using the property of equality in interesting and creative ways in order to make the problem easier to solve. Here's a little motivation for you. It does not matter how slowly you go as long as you do not stop moving. Keep in mind that some people find math to be more difficult than others, but everybody has the capacity to do some high quality mathematics if you just stick with it and take your time and show your work and invest yourself in your goal. And that applies to a lot of other areas of life as well. As always, I do appreciate you stopping in and joining us. Make sure you smash that like button, hit that bell so that you can receive notifications when we publish new material. As always, I do appreciate it very, very much. You guys take care of yourselves, all right? Bye-bye.